Everything set up, PowerPoint, the ohmmeter, and this is a newly cased Arduino project in its aluminum casing. And let's go for that. Hey, what's up, guys? How's the Arduino project in your side? I have a good progress on my side because I already made the casing for my Arduino with respect to the push button switch and the relay. That is the hardware that is attached right now in the A3CS and with the Arduino Uno R3. That's a good progress despite I'm catch the cold. But anyway, our topic for today is all about the manual qualification. Sometimes they call it the reliability of the program code and the hardware. By yours truly, this is the HMI amplifier pump panel of the DR100 watt concept project. And you know that our main objective really in here is that this toggle switch in here, we wanted to change that one with a more novel electronic push button and relay. And again, our main focus today is about the QA and testing. Let's go to the next page. So this is the actual implementation on the aluminum casing right now. The Arduino A3CS shield plus the relay. The relay you can see in here. That is the A3CS shield. That is the push button. And that is my Nathan boy favorite toy. He gave it to me. That I always remember him whenever I do a kind of a presentation or kind of DIY stuff. That's personal, by the way. And how do we going to qualify the function of the relay? I'm just simply using the continuity tester, or what we call it the ohmmeter, such that this side in here is the normally open, this side in here is the normally closed. What it meant by that is that if the relay is deactivated, the normally closed means to say they are connected, and the normally open, they are open actually. That's like open in here. But when the relay is activated, then this will going to be closed, and the ohmmeter or the continuity tester can read to be 0 ohms. Now, right now it is in the ohms. Later on, I'll switch to continuity tester. And then this is how it looks like when the relay is deactivated, which is meant in the standby mode. This is infinity. The reading is infinity. And if it's in the active mode, the relay 1 is activated, and you can read here as 0 ohms, or that is continuity, or this tester will beep. But I can demonstrate it right now, by the way. And then if I'm going to press that one, it's beeping, means to say that the relay is activated. It's so noisy, so I just be in the ohmic value, which is about 0.0025. Basically, it's 0 ohms. Let's go to the next page, and how we're going to qualify that short test. I mentioned here about short test or short reliability test for the program and hardware. We're going to power on and then power off, and when we power on, the LED should turn on, the relay should be activated, and the reading of the ohmmeter will be 0 ohms or close to 0 ohms. And when we power off, LED 1 will turn off, relay 1 will be deactivated, and the ohmmeter, the reading will be infinite. And what we should do for that, like a normal power on, power off, like power off, power on, power off, power on. And then the next one could be like we define how many times we're going to power on and then power off. Maybe 100 times, for example. Is it good enough? Maybe. But normally in the industry, we power on and power off for about 1,000 times using automated test. And the other one is that is it random? Like maybe today you don't want to power on, then you think of power on. So there is no definite time or definite pattern, just a random power on and power off like this. And the next page is gonna be the long reliability test. Long means to say that it requires a longer time. Say for example, when you power on and then power off, the same sequence, the LED on, relay activated, and the reading of the ohmmeter is 0 ohms. But if you're going to do that, it's going to be like maybe 1 hour in the active mode, just like playing the amplifier. That means it will never turn off. If it's turned off, there is a bug. Or could be like 10 hours, maybe means to say that you turn on the amplifier for 10 hours. And what about the power off? So the power off is the same that the LED one should turn off. The relay will be deactivated. Ohmmeter, infinite, it's infinite ohms, no reading. And because this is in the standby mode, that could be like 2 days. Is 2 days is good enough? Or maybe 24 hours, 1 day? Is it good enough? Or is it 1 week in the standby mode, assuming that you put your power amplifier there just in the standby mode for 2 weeks? Maybe you go for vacation and then it's still working. So those are kind of long reliability, which is it requires a longer time. Or if you don't like the long reliability, then let's go whatever you want. You might think of something more in-depth reliability test or qualification test. Then it's all yours, guys. It's all yours. Before we go to the next page, let me have coffee to spirit me off. It's cold today in my apartment here in Dongguan in the Guangdong province in China. And for the strict qualification, so it's the same power on and power off with the same sequence, but this time you just don't have to press the switch like this. Normally that's what we do for a push button, but it is possible that we also, kids will go into part on like they get the press and hold, wherein you can hear that while I'm pressing it, it's the power on and power off, 1 seconds, I believe. And then in the power off also, this is the active mode right now. And assuming that my kid, who I asked him to power off, then he accidentally press it and hold it like this. And then the amplifier keep power on, power off, power on, power off. So well, this is not good basically. This is not what we want because a toggle switch, once we toggle that, it stays there forever unless otherwise you will toggle off. Once again, let me put that one into screaming. Oh, that's it. Yeah, screaming, screaming, screaming. So imagine that, guys. If your power amplifiers keep power on, power off in a very short period of time, probably your amplifier will going to sustain some kind of damage. I already experienced that one with a class AB power amplifier. Basically, what do you think of this? Issue Beric? To me, I don't accept it. I cannot accept it. But let's continue that. So about an abnormal qualification like same power on and power off, but this time you're gonna just press short it, very short, very short. The what I'm doing right now is that this is not the way we do it, like in toggle on, toggle off. We cannot do that one because the way we do that is that the reason why we need to power on the power amplifier is that we want to use it, we want to listen to the music. and we don't want to power on immediately and then power off immediately. There is no make sense to do that. We power on the power amplifier and we use it for, let's say, 30 minutes. Then after that, we're going to power off. That should be included in the program, I should say. And this kind of abnormal qualification is, I included it in here, though it's not happening in the real world, but it's good to put it in here. What do you think, guys? Well, let me include the serial port, not the serial port, it's the data log from the serial communication as a part of the qualification. So it's starting here in the standby mode and power it on, power it off, power it on. Let me do a little bit of the screaming. One more. Power on, power off, power on, power off, power on, power off, power on, power off, power on, power off. Forget about the screaming. It's not nice to the ear. So keep me power on, power off manually. And this is a thing that I don't like so much about manual tests. I always advocate automation tests, that's so-called ATE, the automatic test equipment, wherein I will have the Intel 8051 hardware and programming here, and it will going to test this Arduino project. That's something that I can demonstrate it in the future videos. I hope I can able to make that and keep power off, power on, power off, power on, power off, power on. And I already power on, power off for 22 times already. The last one is going to be 23 times. So if you know how many times you power on, power off, and then you can check what is the data log. Is it always matching with the state of the Arduino power off, power on, power on. And then your verdict, your qualification result, your verdict, if program 3 is good enough, the push button and with the relay, then congratulations if you can accept it. If it is failed or NG, no good, you have some action to do. I have an action to do, which is the action 1. Maybe the programs need to modify, um, fix the bug. Action 2, maybe there is something wrong to be fixed on the hardware, or how many action that I have in action N, and it's a lot of question mark. And finally, this is now your own adventures. While I'm having my own adventure in here, my apartment, in my job set, being an overseas Filipino worker, enjoy the qualification and testing. This is programming, modification, debugging, fixing problems. How many problems is in there? The thing is that we're going to just enjoy the hobby. This is just a hobby, a shareware and coursework for audio lovers, DIYers, and this is free tutorials from me, from the DR 100 Watt Concept YouTube channel. And the bad thing here is about these bugs in here, wherein you press and hold and keep power on, power off. Well, I can make a shortcut right now because I already fixed the problem in program 4. So let's go to program 4, and the program 4 says that it's fixing and improving. So how is that? Let's go and click it, open it up, and then Arduino is breathing, and then it's loaded. And let me see again the board. Arduino AVR is Arduino Uno. The communication port is COM11. That's correct. And I'm going to download that. Compiling, downloading, uploading, I should say. And then it goes with the serial monitor enable right now. So the thing that I have done in here is that when you press and hold, it will not activate it to go to the power on mode or to the power off mode. So let's see the log. So I keep pressing it here, and it says User keep pressing the key and there is no any action, there is no LED, there is no relay activated, and the log says user keep pressing the key. I should say put, hey guys, this is not the way you power on the power amplifier. You are stupid, you know. Well, it's a kind of thing that now I release it and it turn on, LED lighted, and relay is activated. And if I'm going to press just once, and it goes into the standby mode. Well, we're not going to take deeper looks or scrutinize the code in this videos, but rather I reserve that in the next videos, in the future videos, I should say. But for the moment, I have already fixed the problem and you can actually use program 4. I'm confident that this can work and you can put that into the actual application right now to change the toggle switch of your power amplifier into a much novel push button switch, power on and then power off. Well, just have to mention also that I make some kind of light communication between the power on and the power off. Push it once and you can see that there's a light communications. This is something that we can do it with our program to improve the man-machine interface. And it is now in the active mode. You can see it is 0.022 ohms. If I want to put that into the screaming mode, it's screaming right now, but it's too noisy. The next thing is that if I'm going to press and hold, you can see that I press it, hold, and it's not going to power on right now or power off right now. It's just waiting for me to release the push button. If I'm going to release it, then that's the time that it will go into the standby mode. And you can see also that the LED is keep flashing a little bit faster. That will prevent the user to power on once again, because the sense of powering off the amplifier really is that you're going to close the amplifier, not going to power off and then suddenly power on once again in the real world. Let's do that again. If I'm going to keep pressing and nothing happening here, nothing happened. There is no power on, power off the amplifier. Once I release it, take a look at the LED. There you go. It's in the active mode. Well, all of this tutorial is free. I hope if you find it to be beneficial to you, and you may consider to subscribe to my channel, the DR100W Concept Project. This is a YouTube channel, and hopefully for your subscription, likes, and share these videos to anyone who needs it, especially those bloody guys who want to make the power amplifier front panel to be as a beauty as the girlfriends and their wife. I hope so. I hope so.